Hi, this is WB4MDX. This is a very quick overview of a lecture I gave for the East Tennessee DX Association last year. I live in an antenna challenged neighborhood and I needed to get the antennas out of the attic. So I came up with a way to come up with a very stealthy antenna. I live in an antenna challenged neighborhood. I looked at different types of antennas and considered finally looking at an inverted L. I had a lot of obstacles that I had to overcome, needing to get the coax from the attic to the crawl space into the backyard. Also wanted happy neighbors, happy homeowners. We also have weather challenges here, from tornadoes to lightning to hail up to 2 inches in size. We also needed to create an area that was aesthetically pleasing. We had to create a nice garden space. I did try a commercial antenna called a JC Tri-bander. It's 160 through 40. It's a shortened doublet. Primarily was a cloud burner, not much DX. I looked at different types of vertical polarizations, the monopole or folded monopole by WB4MDX, an article that was in QST. It also needed to be low cost. I'd like to try to get as many bands as possible. Due to the restrictions of size of the lot, I needed to have at least 12 radials. Unfortunately, where the antenna was going, it was going to be about 15 feet away from the back property line. I also learned quite a bit about unans, matching. I also learned about common mode chokes and understanding that the more radials you have, the lower the impedance you'll have. I went to simple basics, looking at types of antennas. I wanted an antenna that, again, would possible load multiple wavelengths, as many bands as possible. The question was to go with traps or loading coils or some sort of shortened length. And any gain would be great. Did I want something that was omnidirectional or directional? But most of all, I wanted it to be very stealthy. I felt I wanted a current fed antenna instead of a voltage fed where the current is closer to the ground. This gives a lower angle of radiation, of takeoff angle. Also learned quite a bit about unans using Jerry Sevick's books. It's nice to have an antenna analyzer available to you. I decided on a quarter wave inverted L, where again the current is maximum near the feed point, low angle radiation. The optimum is about 20 to 40 degrees takeoff angle for 160 meters. I really had a hard time getting it to load on other bands, but suddenly I was able to work other countries and started working DX stations. These antennas really don't have much lightning protection, so if we invest in our coax and it gets hit, we're looking at a very expensive item to replace all the coax and unans, this sort of thing. So I tried to come up with a type of lightning arrestor that's a mixture of what's used in broadcasting and different characteristics of lightning. Lightning characteristics simply wants an easy path to ground. It has very high current, tends to vaporize any wire, and destroys just about anything it comes in contact with. It's very deadly, risk of fire and risk of shock. It doesn't seem to like to take tight turns. All articles talk about your ground wire should have big radii of or big curves instead of very tight turns. And it doesn't seem to like to go through very narrow grounded pipes. It'll jump small gaps and large gaps. Primarily it's just unpredictable. So I decided to use a combination of the above ideas. Decided a 1/2 inch copper pipe fed through a grounded 1 inch copper pipe. Also a Jacob's ladder to help bleed off as much or near strikes or if charges were building up. Also wanted to use heavy duty components, and also a steel box to contain a sacrificial coax and unan, and also needed to ground to the main. You also want a static discharge coil made out of old motor wire. It's about 200 turns on a 1 inch PVC pipe. It's going to be sacrificial, so if you get a nearby strike, this is gone. And when you make it, make 2 or 3 at the same time. Put alligator clips on the end so it's easy to change out. The small 1 inch pipe will fit in about a 1 1/2 inch pipe nicely. Also, the lightning trap system is made with, again, Jacob's ladder sacrificial coax. Needed to mount it on a steel post, can use a conductive gel, and attach the radials and ground rods. Also decided to add a common mode choke. It helps prevent radiation from the coax, and also helps prevent lightning from coming back through the coax, and also helps to quieten the antenna further. You might have to use an Unadilla. This is where checking the antenna impedance when you put the system in to decide do you step up or step down. Generally, if you have enough radials in, you're going to have to step the coax down. Also, Jerry Savik's books are very useful how to build Unadillas and parts easily available from Amazon. Again, when we first tried the inverted L, it worked fantastic on 160. Worked my first European station. Found it was really tough to load on 80 meters and other bands. So I got to thinking, what would happen if we took half of an old Unadilla 8040 trap dipole that had a 7.150 trap in it? What if we connected to the same feed point, just half of this? It would look like a gigantic square root sign. So that's how we came up with the antenna design. When we hooked up the antenna analyzer, suddenly all the ham bands were coming into an easy loading with a decent SWR. We'll be showing some pictures of EasyNet and the antenna. This is just a simple diagram of it, of a simple inverted L. You want this part going up as much as you can and over as little as you can. Over here is about 33 feet, and you have a 7.150 Unadilla trap here, and about 22 feet above it. This gets you 40 meters, and the whole length will get you 80 meters. This is just a simple pictorial diagram of the lightning trap and a small common mode choke, the bleeder coil, and the sacrificial coax on the inside. And this is how we made the light part of the lightning trap. This is the outer about a foot long of 1-inch copper pipe, thick gauge, and a 1/2-inch copper pipe on the inside. The simplest way to space it is just get the little yellow washers from the garden section that goes in a hose. It's perfect for holding the proper distance. The top part you want to epoxy to keep the 1/2-inch copper pipe from rotating. Find any good solid metal box that you can attach the system to and put components on the inside. This is the attachment point with just a simple wing nut. The clamp is actually across this junction here, so when you do sweat it with silver solder, it's still clamped in place and will take a full hit. Also, there's a number 4 ground wire using these simple pipe ground clamps that are available at Lowe's or Home Depot. I wanted to use the direct burial type so that nothing would rust. This is an inside view of the sacrificial coax feeding in to just a little grounded bracket, and feeds in to where the bottom part of the feed through of the lightning trap comes to. And this is a vertical placement of the bleeder coil. And you have a secondary lightning trap with, again, just 5 tight turns inside this with another piece of sacrificial coax. This is a view of the backyard. Actually, it's pretty tough to see the antenna. On the QRZ web page, there's a better picture, but this is actually where the main part of the inverted L comes up, and you might be able to see a black wire coming up this way as part of the 40 meter that goes up to the trap to the 80 meter part. Looking at the current pattern using EasyNet on 160 meters, you can see vertical and a little bit of horizontal component. It's primarily a giant donut, and the takeoff angle seems to be fairly good for DXing. On 80 meters it gets a little more squash. The takeoff angle elevates a little bit. However, on 40 meters, where the inverted L portion is, notice you get a little gain coming in the direction of the inverted L. 20 meters, again, a little bit of front to back gain toward the inverted L portion. On 18 megahertz, it actually tunes quite readily, as well as 10 megahertz, it tunes quite readily. 28 megahertz, it starts to get a more porcupine effect, numerous little spikes coming out, and it has a little bit higher takeoff angle. And again, this is a view of the current pattern using EasyNet. You can see both portions of the antenna are involved. And when you do a sweep view using EasyNet, you can see numerous dips, and most of them fall within the ham bands. Actually, you can see a better plot of this on YouTube. Look at WB4MDX square root antenna, and it shows a sweep from 1.7 megahertz up to 30 megahertz, and you'll see the white line on that video will show you the SWR throughout the spectrum, and the yellow line is the impedance throughout the antenna. I've got more projects that I'm working on. Phase 2 of this is actually phasing 2 of the antennas together at my lake house. I'm using an LC circuit for phasing multiband type antennas. I also like to play around with either caging or increasing the bandwidth a little bit, and also looking at a little fine tuning on some of the other bands. And I'm also working on a rotating K9AY antenna for DX reception. Appreciate you listening. Thank you.